Alrighty, let's get this going. We got 3.2. We're solving quadratic equations by factoring. Let's break that down so we know what each part's meaning. First thing is solving equations. Got to see what that means. Quadratic, got to know what that means. And factoring, 3 parts. First one, let's look at solving. Solving equations is the same thing as what's in this getting started here. But this one's a linear equation. Solving means find the value of the variable that makes the equation true. So let's solve this linear equation. We know that it's linear because linear is dealing with the x value. The x value, it has an x to the 1. That makes it a line. When the x value, the degree of the x value is x to the 1. Let's solve it. When we're doing a linear, we want to get all the x's to one side, all the numbers to the other side. So first thing, let's add 3x to both sides. Gives us 7x minus 10 equals 4. And let's bring the 10 over, so we'll add 10 to both sides. That gives us 7x is equal to 14. Last step, divide by 7. So x is equal to 2. That was with a linear though. That was solving a linear. Quadratic. If linear means x to the 1, a line, quadratic means x squared. So whenever you have an x squared is the highest degree in the equation, we're dealing with a quadratic. Factoring, that means we're using the skills from 3.1. Could be difference of squares, could be sum product factoring. All of those techniques and bringing them into here in order to solve. Oh, fun stuff. We're combining chapters here now. We're looking at the first n terms of an arithmetic series is 660. We need to determine the value of n. This is another way of saying solve for n. It means the same thing. Let's go through it. Let's see what happens. Got to start with the formula first. It's arithmetic series, so that's an Sn equals. We have the first term. We can figure out the d. We don't know the last term. We're going to use this formula out of the 2 that we have. Okay. Let's see. Formula-based question. Always write down. Do I know the n? No, that's what I'm looking for. So I don't know the n. The t1, hey, I know that. That's 100, first term there. The d, 95 minus 100, negative 5. And then my Sn. Ooh, I know that. That's 660. Let's plug it in and see what happens. So we got 660 equals n bracket 2 times 100 plus n minus 1 times negative 5. Put it in brackets or else it looks like you're subtracting 5 over 2. First step I want to do, let's get this fraction dealt with. I'm going to multiply both sides by 2. Gives us 2 times 660, that's 1320, equals n bracket 200 plus distribute in that negative 5. We've got negative 5n plus 5. Let's clean it up inside the brackets there. 1320 equals n times. I can combine the 200 plus the 5. That gives me negative 5n plus 205. Next step, distribute in the next n. 1320 equals negative 5n squared plus 205n. What we're going to do now here, we've got a quadratic. I see an n squared. The degree is 2. Right there. That's what's telling me it's quadratic. The steps that we're going to use to solve a quadratic equation is to equate to 0 and factor. You're going to hear me say that over and over again in the courses. So here we go. Let's get it equal to 0. Well, it's better to factor with the leading coefficient positive. So I'm going to move the 5n squared to a way that's going to make it positive. So I'm going to move it to the left. So add 5n squared to both sides and subtract the 205n from both sides. That's gone, that's gone. That's taking it to 0. That's what I wanted. Put them in descending order of the exponents. So that means 5n squared minus 205n plus 1320 equal to 0. That's what I want to get to. And now we're going to use our techniques of factoring at this point. First thing for factoring, look for a GCF. Make it easier on yourself. Oh yeah, they all can divide by 5. Let's take out a 5. Leaves me with n squared minus 41n plus 264 equal to 0. Now let's do our fun jazz. Sum, product, factoring. Sum. That's my middle term. Negative 41. Product. The product is the first term, which is a 1, multiplied by the last term, 264. So that's just going to be 264. Looking for two numbers that multiply to 264, add to negative 41. Well, in order to get to a product that's positive, I either need two positives or two negatives, but I see here that I've got a negative sum. I need two negatives. Do a little bit of guess and check work, and we come up with, oh, negative 8 and negative 33 are going to work. So we factor it. 5 bracket. Because it's a 1n squared, I can jump straight to the answer. Minus 8 times n minus 33 equal to 0. And now comes in what we call the zero product property. If we turn to page 185 there, we'll see that. The zero product property is saying this. If we have two things multiplied to give us 0, or 3, or however many, the only way it's going to equal 0 if we're multiplying is if one or the other or both are equal to 0. So at least one of those two, the A and the B, one of them has to be 0. That we refer to as the zero product property. Show you what I mean here. The only way for us to get this equal to 0 is if the first factor or the second factor is equal to 0. So let's make it equal to 0. N minus 8 equals 0, or n minus 33 equals 0. And now we've got two linear equations. Solve for the n. So add 8, add 8. First one, n is equal to 8, or add 33 to both sides, and we get n is equal to 33. Oh, do a quick check at the beginning, and yeah, either of them do work. So we have two answers. Box them in. When you know that they work, box them in. The reason there's two answers is because we get a quadratic. When we have n to the 2, or x to the 2, this is telling you that there's probably going to be two different answers. So one of the things you have to do in this course is you have to be able to identify when something's a quadratic or second degree polynomial and when it's not. Okay, so that's called a quadratic equation. And as was discussed already, when you have a quadratic equation, equate to 0 and factor if you can. This time right now, everything's going to be factorable in this section. Important, you will be tested on this. Why are these two not considered quadratics? Put down an answer for yourself. We'll discuss it. All right, let's whip through this one. Quadratic equation, it says solve. That means let's equate to 0. Oh, they already did. Nice. And then we factor. Equate to 0 and factor. So sum, middle term. 1. Product. 1 times negative 56. That gives us negative 56. What two numbers multiply together to give us negative 56, add together to give us 1? And I know because it's a negative product that I need one positive and one negative, and they have to be 1 apart. Two numbers are going to be negative 7 and a positive 8. I need the larger of the two numbers to be positive to get a positive sum. Because 1 is the leading coefficient, I can jump straight to the answer, x minus 7, x plus 8 equals 0. And then use that zero product property. Either the first one equals 0 or the second one equals 0. And then solve. Add 7, so x equals 7, or the 8. Subtract 8. X equals negative 8. There's my two answers. Verifying means just plug it back into the original. 7 squared plus 7 minus 56. Does this equal 0? Yeah, it does. If you plug that into your calculator. Do the same thing with the negative 8. Negative 8 in brackets squared plus negative 8 minus 56 equals 0. Yep, 0 equals 0. They both work out. They're both solutions. Now the zero product property is called zero product property for a reason. It's not called the 22 product property. It only works when it's equated to 0. So even though this looks like, hey, we could jump straight to the answer by just taking the first two and make it each equal to 22. Doesn't work. Only works with 0. So we actually have to do some extra work. Even though it looks like it's in factored form, it's not. In this case, this is really the only time you're going to be expanding and then refactoring. It asks for solve. So we're going to expand this, equate to 0, and refactor. Woo! Lucky us. Let's expand it. And we come up with 3x squared minus 18x plus 1x minus 6 equal to 22. Equate it to 0. Combine all like terms that you can. We get 3x squared minus 17x minus 6 equals 22. Give you an extra step. Now equate it to 0. Let's bring that 22 over. Subtract 22. 3x squared minus 17x minus 28 equal to 0. Now we're going to factor again. Yay! Sum is equal to negative 17. Again, where did I get that from? Middle term. Product. Product is equal to the first term times the last term. Don't forget about that. We got 3 times negative 28, which equals negative 84. Should have first of all looked, was there a GCF between 3, 17, 28? No, there's not. So I can't take it down lower. Factors. Two numbers that multiply to negative 84 and add to negative 17. With a little bit of guess and check there, playing around, we notice that, hey, one's got to be positive, one's negative. And the larger number, so it's going to be 21 and 4, the larger one has to be negative because I need a sum that's going to be negative. So we'll put the negative on the 21. These are not your answers. We're going to do decomposition method. Bring down your first term, 3x squared. And your last term, negative 28. We decompose that middle term into the two components. The two components are, put the negative one first if you can, less chance for error. Negative 21x plus 4x. Then we group. Group the first two, group the second two. Pull out the GCF. The GCF between the first two, hey, I can get a 3x out of it. Leaves me with x minus 7. Second one, I can pull out a 4. All right, let's do it. Plus 4. Leaves me with x minus 7. Good. And the brackets have to be exact same thing, or you did something wrong. Now I can pull the common factor between the two of them, x minus 7 out, leaves me with 3x plus 4 equal to 0. Color coordinate that for you again, just so you remember where everything went. Good. And now our friend, the zero product property, says x minus 7 equals 0 or 3x plus 4 equals 0. First one, add 7 over to the other side, x plus 7. Good. Second one, we've got to do it in a couple steps. Let's subtract 4. Leaves us with 3x equal to negative 4. And divide by 3. Gives us x equals negative 4/3. Two different answers. Okay, fun stuff. We do it again. You've got a quadratic, x squared. Equate to 0 and factor. We want them in where the x squared is the positive. Move it that way. And we want them descending order. So we're going to bring over the 30x. Descending order means 3x squared, then 3x to the 1 plus 75x to the 0. And it's equal to 0 now. I've equated to 0. Now I'm going to factor. First step of factoring. GCF. Don't forget that. Let's write it down. Don't forget it. Is there a GCF? Oh yeah, there sure is. Let's pull out a 3. Leaves us with x squared plus 10x plus 25 equal to 0. Hey, much easier to factor. Let's take it over. Sum equals the 10. Product now equals the 1 times the 25, so 25. Two numbers that multiplied 25. Add to 10. Oh, look at that. 5 and 5 sure do. And we can jump straight to the answer because it was a 1x squared plus 5 times x plus 5 equal to 0. This is the same thing as saying 3 bracket x plus 5 squared equals 0. Now I only have one factor that I really need to worry about. What it's saying is the two answers are both the same. An x plus 5 and another x plus 5. So I only need to really worry about it once. X plus 5 equals 0. So x is equal to negative 5. Done deal. Boom. There's your answer. There is only one answer in this one. Really, it was technically two of the same answer. All right, again, equate it to 0. So let's do that. Let's get this plus 20x over, because I want to keep my x squared that positive. That's going to cancel off on this side. Leaves us with 5x squared, descending order, plus 20x equals 0. Oh, my goodness. I only have two terms instead of 3. GCF first. Is there a GCF between these? Sure is. I can pull out a 5x. Let's do it. 5x leaves me with x plus 4. Hey, whoa. I don't have a quadratic any longer to factor. By doing this, I actually factored it straight up. I didn't have to use the sum product factoring. Yay for that one. But how do I deal with it from here? What we've got is our first factor is here with the x. Second factor is there. This is different than the 3 that was in front over on the other question. This did not have an x attached to it. This one has an x attached to it. That's the factors I'm worrying about. I'm solving for the x. So I didn't care about the 3, but I do care about the 5x. So do the same thing. Either 5x equals 0 or x plus 4 equals 0. If you would have taken it over here and said 3 equals 0, 3 never equals 0. It ain't going to happen. Here, 5x equals 0, so then we divide by 5. Oh, look at that. X is equal to 0. There's one answer. Or, do your subtract of the 4. X is equal to negative 4. There's your second answer. Extremely important question here now. Do not skip over this one, because this is where people make mistakes. Why did we not, in their example, divide by 2x? Or in ours, 5x squared plus 20x equals 0. Why did we not divide by the 5x to take it to lowest terms? Think about that one for yourself. We've got to discuss that one in class. Okay, number 3. Whoa, this one's looking a little bit crazier. First question, is that a quadratic? No, there's no x squared. So then why are they putting it in here? I don't know, let's just do it anyways. Let's see what's going to go on, what's going to play out. So we've got a radical. This is a radical equation. Because we've got a radical in it. Okay? Well, in order to solve still means the same thing. What value of x is going to make this work? In order to do it, the first step number 1, is isolate the radical. Let's get the radical all by its lonesome on one side. Well, in order to do that, we're going to take the 4 and move it over to the other side. So subtract 4 from both sides. Gives us square root of 6 minus x is equal to, that will cancel off, 4 minus x. There's step number 1. Step number 2, after we've isolated it, we're going to square both sides. Square both sides. So let's put the brackets around both sides and square them. If we square a radical, square root and squaring are opposite. They're going to cancel each other off. We're just going to get the radicand. 6 minus x. Yes, the radical's gone. However, equals x minus 4, x minus 4. What the heck's going on there? Who wrote that? There we go. Evidence is gone. Can't pause the video and rewind to see that again. X minus 4 squared, that is, take it on the side. It's not x squared minus 16. X minus 4 times x minus 4. Squaring means write it twice and expand it. All right, let's do that. That gives us x squared minus 4x plus 16. X squared minus 8x plus 16. Bring that one back in. Oh, look at that. I have a quadratic now. That's why they put it in here. Equate it to 0, keeping the x squared positive. So let's subtract 6, add x, combine all of our like terms. And I moved it this way so that my x squared was positive. Minus 8x plus an x, that gives us minus 7x. We got 16 minus 6, that gives us plus 10. And then we're factoring. Keep on factoring. 7, negative 7. Product is 10. Okay, what does that give us? The two numbers. Hey, both negatives, negative 5 and negative 2, those ones will work. 0 equals x minus 5 and x minus 2, 0 product property. X minus 5 equals 0, so x is equal to 5. X minus 2 equals 0. Oh, I shouldn't box them in yet. Just a moment. Don't want to box it in until I make sure that they work. And x equals 2. So there's my two potential answers. Here's the problem. The other ones I didn't necessarily have to verify. I knew they were working. But they keep saying verify, verify, verify. The problem is this. Any radical comes with a restriction. The restriction here is this. Can't take the square root of a negative number. If you get a solution that says we're going to be taking the square root of a negative number, then that's a problem. So 6 minus x has to be greater than or equal to 0, a positive number. Let's go and check this. If I plug this in, I get the square root of 6 minus 5 plus 4 equals 5. If it's radical ones, you got to verify those ones for yourself. Got to verify. 6 minus 5. That gives me the square root of 1 plus 4 equals 5. Square root of 1 is 1 plus 4 equals 5. 1 plus 4, that's 5 equals a 5. Oh yeah, hey, that one works. Good, so I can box this one in. Got to verify the second one. Square root of 6 minus 2 plus 4 equals 2. Let's see if it works. 6 minus 4, that's the square root of 4 plus 4 equals to 2. Square root of 4, that's 2 plus 4 equals 2. 2 plus 4 is 6. Hey, that is not 2. This one's called an extraneous root. It's an extraneous solution, extraneous answer. It's an answer that did not work. It's going to happen when we've got square roots. Didn't happen in the other ones, but it will happen for these. So the only answer that actually works is x equal to 5. I'll talk about more extraneous stuff in class. All right, let's finish off with the puzzle type questions. These are our problem solvings. Hey, let's bring it in. Let's do the thinking. Important stuff. Real life doesn't just give you the numbers. You got a situation you got to weed through in order to be able to use your math. The sum of a number and the square of a number is 20. Okay? Now I know a lot of these questions you'll be able to just jump to the answer. Process is what's important though for me. The sum of a number. They didn't give us anything, so we want to use a let statement. Let, whatever, n, x, I'll just use x. Let x equal the number. They didn't give you a variable, you must define it. That's step number 1, you got to do that. Okay, the sum of a number, that means we're adding. So the sum of a number and the square, not the square root, the square of the number is 20. Equate it to 0 and factor, that's it. X squared plus x minus 20 equals 0. Put it in descending order. Factor, we want the sum of 1 product of negative 20. Two numbers are going to add to 1, multiply to negative 20. Those two numbers are going to be 5 and negative 4. So we've got two answers. X plus 5 and x minus 4 equals 0. Zero product property. X plus 5 equals 0 or x minus 4 equals 0. Subtract over the 5. X is equal to negative 5. Or x, let's add the 4 over. X equals 4. But whoa! We can't box both answers in because we got a problem solving question. We got a real life number. We have to look here and say, will both of these numbers work? Got to check them. Hey, let's check it out here. So the sum, if we take negative 5, can I put it in there? Will it work? Yeah. Work it through in your head. Check the 4. Yeah, it'll work. Here as well. If we were talking about an area, just like their example 4 right out of the textbook, they were talking about area. That means I can't have a negative area. So this first one would have been a no-go if we were talking about a situation where you can't have a negative length. In this case, it's good to go. It's good to go. Two answers. Written question, written answer. The numbers are negative 5 and 4. I highly recommend you look at the question number 4, the example 4, in your book. It's quite a bit different than the one we just did, a little more difficult as well. So please look at how they work through that one. I'm going to discuss some of those types of problems as well. Okay, bring your knowledge together so that we can discuss some of these important concepts and take you to the next level of understanding. See you in class.